Algebra 2 Honors, Day 2 of Conics, circles. We have looked at circles. We've looked at the unit circle when we were doing trigonometry. The unit circle being x squared plus y squared equals 1, which is a circle centered at the origin with a radius of 1. Today we're going to look at shifting, translating the circle. And so then we have this new equation where we have moved the circle to a new center hk with a radius of r. Excuse me. I'm just going to go down to a new page here and just to review from geometry, if you would have had x minus 2 squared plus y plus 5 squared equals 16. This would be a circle of center to -5 and a radius of 16. And so on your graph, you would go to the right 2 and down 5, and there would be your center. And oops, I said radius of 16, sorry about that. This is your radius squared. The radius would be 4. And then from your center, you go up 4, you go to the right 4, you go down 4, you go to the left 4, and you draw that beautiful circle. Yeah, oh, there, it fixed it for me. Okay, so anyways, so that's a little bit of review from geometry. So we are going to be working to get an equation into this form by using the process of completing the square. Before we get to doing one of those problems, there's a little bit of a review and a warm-up, and one of your homework problems has this in here. So I want to just go through this. You should be proficient at writing equations of lines. And so right here, slope is change in y over change in x. You need to subtract in the same order. So when I choose to go 7 minus 8, I must do 2 minus a -3. And you get a -1/5. Now to write the equation of the line, I like the point slope form. I think that's the go-to form when you're in higher levels of math. Unless you know directly the slope and the y-intercept, I go through this, which is called the point slope form. And so you need to choose a point, and you can choose either of the points that we used for slope. I'm going to choose 2, 7, and we plug that in. And then they want it in slope-intercept form, which is y equals mx plus b. So I'm just going to distribute the -1/5, add 7, to both sides, and then we have y equals a -1/5 x plus 37/5. And that is your equation of your line. All right, let's get to the circles and getting them into this standard form. And we're going to use completing the square. And to complete the square on this, it needs to have the coefficients of both the x squared and y squared. The coefficients must be 1, which they are in this first equation. So we are going to write down x squared minus 6x, leave space to complete the square. Y squared plus 10y, leave space to complete the square, and move the 22 to the other side. We worked on completing the square last fall with parabolas, and so it is a skill we've used. To complete the square on the x squared minus 6x, we take 1/2 of that -6 and square that value. And a -3 squared is 9. And so that's going to complete the square for the x squared minus 6x. But if I add 9 on the left side, I must add 9 on the right to keep this balanced. Do the same thing for the y squared. 1/2 of the 10 squared, which is 5, and 5 squared is 25. So we add 25 to both sides. And then we made a perfect square trinomial, so we can write it as a square of a binomial. And so this will be x, and it's always half of what that coefficient of x was. And then it is that binomial squared. Don't forget the squared. And then with the y, it's going to be half of what that coefficient of y, the y term was, which is 5, that quantity squared. And then on the right-hand side, we get 12. So the center of this is 3, negative 5. And the radius is the square root of 12, which is 2 root 3. And for graphing purposes, you're going to need to approximate the value of the radius. And if you don't have a calculator, you just guesstimate, but you should have some reasoning behind it. You should know that square root of 12 is between the square root of 9 and the square root of 16, whose values are 3 and 4. So the square root of 12 is somewhere between 3 and 4. So you just estimate if you don't have a calculator. I would expect it, you don't use 3.1, you don't use 3.9 because 12 isn't super close to 9 or super close to 16. So I would accept different values for that, but it's approximately 3.5. So we've got the center, we have the radius at 2 root 3, and then we go to graph. To the right, 3 and down, 5. And then from that center, go up the radius value, 3.5. To the right, 3.5, go straight down, 3.5, and to the left, 3.5, which should put you to the left of the y-axis, and then attempt to draw that circle. I'm hoping it's not going to correct it for me, but that's what we do. All right. Now, in the next example, we need the coefficients of x squared and y squared to be 1. And when it is a circle, this equation in this form, the x and y squared values will have the coefficients being the same value. If it's going to be a circle, the coefficients of x squared and y squared must be the same. Otherwise, it's something else, which makes it a little easier because I can just simply divide by 2 on both sides. And if you get fractions for the coefficients of x and y, you just have to work with fractions because x squared and y squared must have coefficients of 1. So in doing this, I get x squared plus 8x, leave room to complete the square, plus y squared minus 2y. And then 2 divided by 2 is 1, and I'm just going to move that to the other side. And 0 divided by 2 is 0. So 2 divided by 2 is 1, and I moved it to the other side in preparation to complete the square. Now, to complete the square, we take half of 8 and square that value, which is 16. So that will complete the square for the x squared. I must add it to both sides. For the y, we take 1/2 of the negative 2 and square that value, and negative 1 squared is 1, so we need a plus 1, and if I add it on the left, I need to add it on the right. And then the x squared plus 8x plus 16 factors to the square of x plus 4, quantity squared, don't forget the squared. Y squared minus 2y plus 1 factors to y minus 1, quantity squared. What goes here is always half of the 8, what goes here is what is half of that negative 2. Oops. All right, and then on the right-hand side, we get 16. So the center of this is negative 4, positive 1, and the radius is 4. So we go to the left 4 and up 1. And from that, we go up the radius length of 4, to the right, the radius length, down the radius length, and to the left of center. And then we draw our circle. Ah, that time I corrected it. There we go. So there's that circle. And moving on then, find the distance between the two centers in example 2. Well, the two centers are 3, negative 5, and negative 4, 1. And I expect that you're proficient at the distance formula. And the distance formula was on yesterday's homework on the parabola, so you can look at that if you don't remember it, but you are expected to know it and be able to use it. And it's the change in x squared and the change in y squared. Oops. And we get 49 plus 36, which is the square root of 85. And that doesn't simplify. It's like 5 times 17, which are prime numbers. So that's it. That's the distance. To find the midpoint between the two centers in part B, well, the midpoint formula, when you have two ordered pairs, that midpoint formula is, I don't want to use slope. That midpoint formula is you average the x's, you add them up and divide by 2, and you average the y's, you add them up and divide by 2. So, the midpoint between the two centers is going to be add up the x values and divide by 2, add up the y values and divide by 2, and that midpoint is -1/2, -2. Example 4. We have a point on the unit circle, and there's that equation of the unit circle. It's a circle centered at the origin with radius of 1, and it's in quadrant 2. There must be some reason they're giving that to me. And they tell me that the x-coordinate is a -12/13. Find the y-coordinate. Well, if this point is on the unit circle, the ordered xy pairs satisfy that equation. If I plug in for x and in for y, I get 1. Well, they give me the x-coordinates -12/13, so we are just going to plug that in for x, and that just leaves y in the equation, and we can solve for y. So we get 144 over 169, and y squared. Okay, I'm going to have to subtract, and so I need a common denominator, so I'm going to write 1 is 169 over 169. And I have y squared is 25 over 169. And so that means y is plus or minus 5/13. When you take the square root, you get plus or minus. But they said that this was a point in quadrant 2 where the x-coordinate is -12/13. And since you're in quadrant 2, that tells me y has to be positive, and so your final answer is y is a positive 5/13. I like to see the step where you first show it's plus or minus, and then to me, then when you box that the positive answer, to me that makes it look like you know what you're doing, that you're choosing that it is positive because it's in quadrant 2, rather than you just lucked out and it was positive and you weren't thinking about it being possibly negative at all. All right, so the next one, the equation of the circle is given. Find the x and y intercepts. Well, when I'm asked x and y intercepts, what should come to mind immediately is that the x intercepts occur when y is 0. If I go back to the circle in the above example and I look at an x-intercept, 1, 0, the y-coordinate is 0. X-intercepts occur when y is 0. Y-intercepts occur when x is 0. And so what we can do is let y be 0 in the given equation. And it works actually for solving just to leave the x minus 4 squared, because we get 16 here, we get 16 here, and when you subtract, then that x minus 4 is, that quadratic is factored, and for that to be 0, it'll be 0 when x minus 4 is 0, so x must be 4. And the point associated with that x-intercept is 4, 0. To find the y-intercept, that occurs when x is 0. So we want to plug 0 in for x to find the y-intercept. And we get 16. Again, it works to just leave this factored, because when I subtract 16, I get y plus 4 quantity squared equaling 0. That can only happen if y plus 4 is 0, so y is negative 4, and that point is 0, negative 4. So that is your y-intercept. Then it says find the distance between the x and y-intercepts. Well, you need to use the ordered pairs on that. And again, the distance formula. It is change in x plus change in y squared, and we get 16 plus 16, which is the square root of 32, which is 4 root 2, and that is the distance between the x and y intercepts. Number 31, use the equations to determine whether the line is a tangent, a secant that contains a diameter, or none of these. Basically, you just need to graph and then determine what happens. A tangent line touches the circle at one point. A secant is a line that goes through the circle and intersects it at 2 points. A secant that contains the diameter means that that line goes through the center. And none of these is going to be if the line doesn't intersect the circle at all. So in 31, we have a center of 5, negative 1, and the radius is 2. And so we go to the right, 5 and down 1, and a radius of 2, go up 2, right 2, left 2, down 2. There we go. And so there's that circle. And for the line, I expect you know how to graph a line. You've got your y-intercept down at negative 3, and the slope of that line is 1/5. So you work from that y-intercept at negative 3, and you can go up 1 and then right 5. Or if needed, negative divided by negative would also be positive 1/5. You can go down 1 and to the left 5 to get points. And so just a matter of which one do we want to use, which one gets me going towards a circle. And it is the go up 1, right 5, up 1, right 1, 2, 3, 4, 5, up 1, right 1, 2, 3, 4, 5. So there we've got points, and that line is intersecting the circle in 2 points. It doesn't go through the center, so it doesn't contain a diameter. So this is a secant line. And you just see that by inspection after graphing. So explain your reasoning isn't really what I'm just, it's use the equations to graph them, and from the graph determine. The graph is what you're doing your reasoning from. Okay, example 32, center is at negative 3 and up 6. The radius is 5. And so we go left 3 and up 6. Radius is 5, so if we go up 5, you're going to be off by 1. And then draw your circle. Oops, that didn't work out so good. Let's undo that one. Try again. Okay, we're just going to leave it rough like that. All right. And so then the line has a y-intercept at 2, so right here, and a slope of negative 4/3. So I could go down 4 and to the right 3 to generate points on the line, but that would also, I could have the numerator positive and think of the denominator as negative, and I can go up 4 and left 3. And this is the one I'm going to use because that's going to get me into the circle. I could actually use both to get some points. So if I go up 4 and to the left 3, I end up right on the center. Right there, that tells me this is going to be a secant that contains a diameter because the line's going through the center of the circle. If I go up from there, up 1, 2, 3, 4, and to the left 3, I'm here. So maybe I could even go down 1, 2, 3, 4, and to the right 3 and put a point. Now if I can get kind of a line actually going through. And because it went through the center of the circle, this is a secant that contains the diameter. The other thing is it just also means that this circle, I don't have it quite drawn perfectly, so it's probably a good thing it didn't automatically put it through there. The circle just wasn't quite drawn perfectly, so that circle actually intersects at the end, at those points right there where the line was. So anyway, there is that. And then write an equation of a circle with a diameter that has these endpoints. Well, you've got a circle, and you've got a point 4, -7, and a point 4, 1. Well, I don't want to draw this very accurately. The idea is if I find the midpoint of those, I will have the center, and if I find the length, I get the length of the diameter, and half the length of the diameter is the radius. So distance formula, change in x squared plus change in y squared. And that ends up being the square root of 64, which is 8. That's your diameter. And so your radius is 4. This is your diameter length. Radius is half your diameter. And then the midpoint, that's why we did that in an earlier example, is that you average the x's. You add them up and divide by 2. You average the y's, add them up and divide by 2. And that center, the midpoint is the center of the circle. So you get 4, -3. So your equation goes x minus h squared plus y minus k squared equals r squared. And this is your hk. So you get x minus 4 squared plus y plus 3 squared equals 16. And that is your equation of your circle. Don't forget the squareds. Sometimes people forget the squares on those, and then it isn't a circle. That's it.